All right, we are going to try to get my presentation tomorrow done by 4. And to do that, I'm going to get the intro video out of the way. So let's do it. I always pick some papers about pointer analysis, and usually they're quite hard to read. It turns out, though, that this year the papers are not really about pointer analysis themselves. They're about ways of scaling pointer analysis, which is pretty interesting. So interesting in the sense that it's like haha interesting, not like interesting. Anyway, the idea is how can we do this extremely expensive analyses and do them in some sort of reasonable time on reasonable hardware. And so I guess we should first of all talk about what pointer analysis is and why it's expensive and different ways that you can have it be more precise. So the idea with pointer analysis, and I guess I could have a slide here, but I don't, is that you have two variables, two pointer or reference type variables in a program. And so you have a variable x and you have a variable y. And so the question is whether they might possibly alias or whether you know that they're definitely pointing to different objects. For instance, you have x is new foo and y equals new bar. And it turns out that if foo and bar aren't related types, then you know that they don't alias. That's easy, but of course it's much harder if they have potentially aliasing types and maybe they get assigned to the same thing, maybe they don't, who knows. So the key question is, do variables alias? And then the second key question is, if you have a method called O.f or O.m, which method are you actually calling? Because it could be on the declared type of O, or it could be on any subtype of the declared type of O. And it's important to know that. So there's a bunch of applications of this pointer analysis, and so we want good pointer analysis to get better analysis results. And how do we get better pointer analysis? Well, because these things often depend on what happens interprocedurally, then an intraprocedural analysis doesn't get you very far at all. And so you go interprocedural, and then, so if you think about it, there's this thing called context, and it's like, well, you have method f, and what matters is who is calling f. Is it being called from some method g? And is that being called from some method h? And so that's not very formally, but that's kind of the notion of context sensitivity. There's also the notions of object sensitivity and type sensitivity, which are alluded to in the papers, but it turns out they aren't actually important for understanding the contributions of the paper. So we won't talk about them too much, but it's like, okay, how deep in a call stack do you go to a first approximation to get these pointer analysis answers? Okay, so that's pointer analysis. And so that's pointer analysis in not very much detail. In my presentation, I'll give some examples to give a bit more detail, but not in this one. So let's talk about what each of these papers does in particular. Okay, so we have the paper that I am not going to present, Chianina. And so this is a thing where basically they use disk space to make pointer analysis run with context sensitivity, although they don't really say, I guess they don't say what they limited context sensitivity to. And they run it on desktop machines in tens of hours, which is better than previous state of the art, but it's still really quite slow. And we should talk about how useful that really is. So one thing I want to point out here is that technology changes, and so we have SSDs now, solid state drives, and that makes things that are feasible now that really weren't very feasible in the past, right? That would be way too slow to do on a rotating disk. Okay. Yeah, so the disk thing is a key thing, and then the abstract also says something about the evolving graph formulation. It's interesting. I said these aren't really about pointer analysis, and so this paper says, note that our work makes no contribution to static analysis algorithms. Also, another thing about these is that they are PLDI and OOPSLA papers, and you can assume that the audience at these conferences really knows about pointer analysis, and so they don't do a lot of explanation about what they are, which is appropriate in this case. So, yeah, the Chianina paper also does, parallelization, right? And it is kind of domain specific, so it's kind of interesting, but it's also not that domain specific to pointer analysis. It's kind of a standard parallelization. Okay, I think that's all I'll say about that today, and I have some more comments which I'll keep for our discussion of the paper. And then let's talk a bit about the other paper. And so making pointer analysis more precise by unleashing the power of selective context sensitivity. And so it's like, okay, context sensitivity is expensive, and there's a bunch of different approaches. And so how do we get better results? Well, we try all the approaches, and that seems like it might be kind of dangerous because then you just get stuck by the slowest approach. But I guess the idea here is to avoid the most expensive approach and only run the approaches that are not expensive on the methods that are not expensive. So you kind of try to dodge the landmines, I guess, is one way of putting it. And then there's also a way where they can accumulate precision from one approach to another, and we will talk about that in more detail. Yeah, so this work integrates previous works like Zipper E and Scalar, and it uses them to get more precise results by doing that. And it also is implemented in Dupe, and it just so happens that Dupe is what is currently running on my computer right now. Fun, fun, fun. All right, well, we will leave it there, and we will talk about these papers on Wednesday. See you then.